Hello viewers, welcome to this episode on research methodology. Today we are going to talk about quantitative research. While doing so, we are also going to talk about qualitative research and the differences between qualitative research and quantitative research. Towards the end of this episode, we are going to talk about scale of measurement. So, let us start. Data are everywhere, and we are constantly being exposed to them. Like the distance you cover while attending your office, time consumed in completing a chore, your heartbeats, rate of your breathing, the weather today and yesterday, your feeling towards a person, your appreciation to a good work done by one of your neighbors are all data. One might notice that the data expressed in terms of some numbers, like the time consumed, distance covered, can be compiled, remembered, and compared without much difficulty, and sometimes routinely. In comparison, the data which are expressed in terms of feeling, emotion, etc. are difficult to compile and compare. And in some cases, these are not comparable without error. The first type of data is generally termed as quantitative data and later type as qualitative data. Quantitative research is built around quantitative data. It is the process of collecting numerical data through standardized techniques and then by applying statistical methods to derive insight from it. Qualitative research, on the other hand, is somewhat subjective, and the same data may be interpreted different ways by different persons. Here, the data are recorded in a qualitative way uniquely and is not generally comparable with each other. Numbers normally represent absolute values. That is, it is unique and irrespective of the backgrounds and inherent biases, if any, the readers would more or less assign the same value to a number. Therefore, it is rightly said that numbers do not lie. Thus, if a particular item is expressed in number, it is very easy to compare with a similar item. We can also express the differences in terms of percentage, in fraction, or in ratio. For example, if a weightlifter is lifting 60 kg in snatch, we can say that this weight is 2 times more than another lifter whose record is 30 kg in the same event. Other way around, we can express that latter's weight is half of the former. We can very well understand the distance between the third inch and the fourth inch of a measuring scale is equal to the distance between the 9th inch and the 10th inch. In both the cases, it is 1 inch. Thus, if we are capable of expressing an event or happening in terms of a number, it is understood consistently throughout the universe. Quantitative research basically tries to express the events in terms of numbers rather than in the form of text, sentences, emoji, pictures, or paintings. Qualitative research, in many cases, a word or a sentence can express a particular phenomenon or event very beautifully. For example, if you read the following stanza of the famous poem Stopping by the Woods by Robert Frost, you would feel the emotion much better than any other forms of expression, leave alone the numbers. The watcher, woods are lovely, dark and deep, but I have promises to keep. Beautiful poems, stories or novels are written in terms of carefully chosen words, phrases or similes to express the feeling of the writer. But then, in the process of communication, the reader is not bound to feel the same emotion or understand the same meaning as a writer or the poet is trying to imbibe into the bunch of words. For example, if you go through the first above lines carefully, you could have mixed feelings while visualizing the scenario. And this may not be necessarily the same with your best friend. This is more or less like abstract art, which the admirers might visualize from different perspectives. Qualitative expression is capable of capturing the mood of a situation in a localized context, and in most cases, correctly. This is because in the qualitative way of recording an event, we'll always have a tendency to measure in detail, as the researcher shall not be bound by many rules and procedures. So, he or she can dig deep into the situation and can bring out the truth. Unfortunately though, since the researcher shall not be dealing with many such similar events or situations, it will be difficult to generalize the findings. Let us take a business-related example. Say, there was a labor unrest in a small factory, and the factory had to be shut down for a week due to these disturbances. A researcher specializing in industrial dispute worked on that problem and found that unrest was due to some societal disturbances and not related to the factory as such. However, this finding may not be applicable to most of the other industrial disputes arising in other factories, because the earlier problem was localized. There exist a few other shortcomings of qualitative research, like it always needs trained and experienced manpower to conduct such research. There is a huge possibility that such studies will be looked through the eyes of the researcher, which is known loosely as reflexivity, and thus contains an inherent danger of biased analysis, which might be intentional or unintentional. Even with these shortcomings, qualitative research has been used by a large contingent of researchers, and they are reporting good and robust results also. There has been arguments, inconclusive of course, as to which of these research approaches is superior to the other. In my opinion, both approaches are useful in different situations, and sometimes both approaches can complement each other nicely. However, in this discussion, we shall be confined to quantitative research, and we will focus on how to go about conducting one. I have structured the discussions in the following way. First, we will be talking about the measurement process. Then, in another video, we will be talking about the sampling and the sampling procedures. And after that, we will be talking about hypothesis formulation and testing in an attempt to generalize the sample characteristics to the entire population. But later too would be discussed in a different episode. So let us first talk about the measurement process. An event or a phenomenon may not be measurable as such in one go. For example, if you want to find out body mass index, which is also known as BMI of a person, you need to know what is the definition of BMI or the formula of measuring it. So you need to know the definition of the phenomenon that you want to study. World Health Organization defines BMI as a measure for indicating nutritional status in adults. It is defined as a person's weight in kilograms divided by the square of the person's height in meters. If you closely notice the definition, you will see two distinct variables through which you can find out the BMI of a person. They are: one, the weight in kg, and two, the height of the person in meter. So your job is therefore to measure the height and the weight of the person separately in the given units. Thus, in order to measure BMI of a person, we have to measure two distinct variables that constitute that phenomena. This process of finding out the variable or the variables that constitute the phenomena, which is also known as sometimes as event, and then measuring the variables in the right unit without any error is known as the measurement process. This is very crucial for error-free measurement of the phenomena. The broad units referred to above is known as the scale of measurement. The basic objective of the measurement process is to assign a number to the variable of interest. In the above example, that was BMI. We finally assigned a number to both the variables, which in turn gave us a BMI value also in terms of number. Thus, the measurement process can loosely be defined as the process of allotting numbers to variables and thus finally to the event and phenomena, so as to make them comparable to each other. The objective of measurement is to transform the characteristics of objects into a form that can be analyzed by the researcher. Therefore, the phenomenon under study must be defined so that this can be measured accurately. Many researchers, especially the student researchers, blunder here and try to measure the phenomena without predefining it. So let us now talk a little bit about definitions in research. An important part of practice of research entails construction, use and modification of definitions of objects or phenomena. Attitude, aggressiveness, leadership capabilities, job satisfaction or the BMI as mentioned above cannot be measured as it is, since it is not possible to describe these objectively. Vague definition cannot be measured and therefore cannot be used for further decision making. Here, definitions can be distinguished into two classes: constitutive or conceptual definition and operational definition. Constitutive definition is roughly similar to a dictionary definition. A constitutive definition is an element of scientific process in which specific concept is defined as a measurable occurrence. It basically gives you the meaning of the concept. It is fundamentally used in the fields of business, philosophy, psychology and communication studies. Following the establishment of a conceptual definition, the researcher must use an operational definition to indicate how the abstract concept will be measured. An operational definition establishes the meaning of an object through specifying what is to be observed and how the observation is to be made. An operational definition is demonstration of a process, such as a variable, term or object. Relative in terms of specific process or set of validation tests used to determine its presence and quantity. The characteristics narrated in the operational definition in this manner should be such that persons other than the definer can independently measure the characteristics at will. That is, we must be able to count, measure, or in some other way gather information through our senses regarding the phenomenon independent of the person who is defined it. For example, we know that some wise farmers can predict the weather for the near future without using any scientific instrument. Such privileged ones can use their intuition using many current factors like the formation of the clouds, temperature, humidity, wind flow, etc., etc. But these intuitions are person specific and none other than the person can predict with that accuracy. But had the wise man operationalized his intuitions in terms of the variables he measures and their relative importance he places for the prediction, his sense or intuition would be more transparent and another person would have used these cues with reasonable accuracy for predicting the weather. The definition of measuring BMI discussed earlier is an example of operational definition. Another simple everyday example of defining is a cake in terms of how it is prepared and baked. That is, its recipe is an operational definition. Measurements and operational definition go together. That is, researcher will have to get an operational definition of the object under investigation. In day-to-day research, measurement process involves using numbers to represent the phenomena under investigation. However, in qualitative research, this concept of measurement is often not applied. The measurement process converts the happening in the empirical system finally into the number system. Empirical system signifies natural environment, maybe as in the market of a product, or laboratory environment as in a physics laboratory. Through measurement, first we convert this phenomenon into abstract system in order to finally assign a number to the variable and finally to the phenomenon or event at the end. Remember, when we talked about the BMI, I referred to certain units of measurement for both the variables. These units can be termed as scales of measurement. Each variable could be measured in different scales or in the same scale. There are 4 basic scales of measurement which are developed around the characteristics of the number system. This is because a number is not necessarily always behaving as a number. Sometimes it takes different avatars. Just remember the jerseys of famous players like Sachin Tendulkar of India, Pele of Brazil, Platini of Italy, Messi and Maradona of Argentina. What is the similarity? Yes? The colors? No. Then? Yes. You guessed it right. The number of the jerseys. What is it? 10. Right? Now wait a minute. Normally, one 10 is equal to another 10, then another, and then another. Now tell me, does this mean that all players are equal? Messi, Maradona, Platini, Pele, and Sachin too? I know what you are thinking. How can it be? But then all are having the same numbered jersey. Then why it cannot be? Now wait, let us stop this debate here. In this case, the numbers are not signifying anything except for giving uniqueness to the jersey and thus to the players within the team. and nothing else. So this number 10 is like a name only and does not signify any other characteristics of the number system. This type of numbers represents nominal scale, as it represents only a uniqueness to the variable of interest. Second type of scale of measurement is ordinal scale, where a number can describe the position of the sample or the subject with respect to others in a given context. Say, a merit list obviously has one and only one number assigned against each candidate. Without this number, the list is incomplete and incomprehensible. This number represents the position a candidate occupies in the list. Thus, a person appears with a lesser number has more chance to get admission into the class than a person with a larger number. This is very crucial for waitlisted candidates, as you could assume. Here, the numbers allotted contain two distinct characteristics: uniqueness as well as the order or the position. This type of number represents ordinal scale. Thus, a number in ordinal scale has uniqueness and order, two important attributes of the number system. Another very widely used scale of measurement is known as interval scale. Here, we assume that a number assigned to measure a variable will have three important characteristics: the uniqueness, the order, as well as the equality of difference. That is, the difference between two adjacent numbers would be equal to another two adjacent numbers. Like as we discussed earlier, the differences between the third inch and the second inch will be equal to the difference between the 7th inch and the 8th inch in the same measuring tape. Here, the assumptions of equality of difference is very important. In social science research, especially, we have to deal with situations like measuring liking and disliking in terms of particular variable of interest. For example, we may be interested in a person's liking of a painting. We may ask them to rate the picture according to their liking in a scale of 10. That is, a scale of 1 to 10. If she likes the picture very much, she would be respond with a 10, and if she does not, she would be responding with just 1. She may choose a number in between 1 and 10 depending on a level of liking of that particular painting. Here, normally we assume equality of the differences between two adjacent numbers, say between 8 and 9 and 4 and 5. For better understanding, you can visualize a ladder with 10 steps with equal distance between two steps. One should be very careful in assuming this equality, because it is not only you who are assuming this equality, but the respondents also should be able to understand this and respond accordingly. And it becomes more complex when we need to take responses from a large number of persons. Chances are that the respondents shall make mistakes, and as if they are offering a rank. And as you can understand, the rankings signify only ordinal scale. The concept of ladder can make the respondent understand this equality of difference very well. And the United States organization, the United Nations Sustainable Development Solutions Network, while measuring World Happiness Index, used the concept of ladder while measuring relevant variables. There are different types of interval scales, like the bipolar scale, social distance scales, etc., etc. But in order to treat these scales as interval scale, one must be very careful while formulating the measuring instrument, say a questionnaire, or else we might land into deep errors. The final scale of measurement is known as the ratio scale. This scale possesses all characteristics of the number system. It has uniqueness, order, equality of difference, and equality of ratio. Examples of this scale are income of a person, age of a person, weight of a product, and so on. Ratio scale is said to be the most powerful of these four scales, as you can use all statistical and mathematical tools as found relevant to analyze ratio scale data. We can use most of the tools for interval scale data also, if we know for sure that the data is compatible to the assumptions of equality of difference. However, the data measured in nominal scale have limited usability, as most analytical tools are not suitable for such data. We shall discuss this in detail in another episode. Hope you enjoyed this lecture, and I sincerely hope that you understood the concept of quantitative research, its difference with qualitative research, the weaknesses of qualitative research, and also you could understand the concept of measurement. In another episode, we are going to talk about sampling as well as hypothesis testing. Till then, take care and thank you very much for watching this video.